So this video is going to cover a few high-level concepts in ROS. The first one being nodes. So we're going to just go over here to our SSH terminal. I'm inside, and this will be covered in other videos, how to compile new scripts. But we're inside what's called Catkin Workspace. Inside of a directory called source, we created a ROS package called PiCar, and we're in the source folder. And this is where you can see all the different scripts we have. So you can see we have one for our A-star, we have one for our camera, we have one for publishing the motor commands, health data, we have a script for the IMU, which is something we've added to the car. We have a main one that brings it all together, and then we have what's called motor subscriber. So this is going to listen for motor commands and then send those to the motor. And then we have our ultrasonic publisher. This is going to be publishing the ultrasonic data. Now, each one of these is set up as a node. So to run a specific node, we're going to do ROS run PiCar, because that's the name of our module. And then we're going to do the name of the script. So if I do health pi and then I do ampersand to put it in the background, now we're going to have that node is going to run in the background. So if we type in the command ROS node list, it's going to now show we've got health pub running. And then ROS out is just from the standard ROS core system. And I already ran that before, but to run that, you just type in ROS core. So we now have that running, and let's go ahead and run another one. We're going to run PiCar, and we're going to do encoder pub, which is the encoder publisher, and we'll run that one in the background too. Okay, so now let's do ROS node list, and now we can see we have two different ones running. So let's dig into this a little bit further. So we have this idea of topics. So what happens is that this is how messages are sent through ROS. They're sent on these topics. So if we type in ROS topic list, we can see, we ignore the ROS out. We don't really ever use ROS out or ROS out ag. But we have the encoder pub node is publishing data on /encoder, and health pub is publishing data on lowercase health pub. So we can actually look at these messages right now. So this is more for diagnostic and to kind of get an idea of how ROS works. So if we type ROS topic echo encoder, nothing happens. Now I'm going to physically take the wheel of the car and I'm going to move it by hand, and I moved it one step. So I felt the motor just move a little bit, and it's going to publish. Which motor? Motor 1, value 1. I'm going to move that motor forward one more time, or two more times, and you can see it then publishes that data. So the idea is that there's some other node in the system that's saying, well, there's something from encoder that I want that value, and I want to make some decision or do something with it. So we can just hit Control-C to close that. I'll do it one more time here, and I'm going to do the other wheel. I think actually we may only be publishing on one wheel, but we can take a look at the script and see. You can see though is that we end at 33, and if I'm going to move it forward 2 clicks, 1 or 2 clicks without this echoing, that data is still being sent. And now if we do ROS topic echo and I move it 1, we should see it skips a few. You can see we have 33, and then it jumps to 36. So once these messages are sent, they're not queued. They're sent, they're gone. So if you didn't have a script running, you're going to miss that message. So again, there's no kind of queuing mechanism to this. Let's take a look at the other one. So now health publisher, that is more of a continuous flow. So let's say ROS topic echo health pub. And it's I think about every second, we're taking the data from the system. So we've got the voltage, CPU temp, GPU temp, CPU temp. And what you can see is that this data is encapsulated in something called a message. And a message is a lot like a C++ struct. So if we kind of think back, we've got nodes, which publish or subscribe topics, and topics contain messages. So we're going to go back into this folder called message, and this is where we define the message for each of these. So if we do encoder.message, we always start with a header, which is going to be timestamp information. We're not using it right now, but it's good practice. If you needed to correlate two different sensors at the same time, this way you've got timestamp information you could be referencing. So you can see what we do is we're using an int 8 for the motor ID and an int 16 for the value, for the encoder. And if we look at the health message, and you can see you've got a float 32 for these four values, and you can see those here: CPU temp, GPU temp, CPU usage, and voltage. And these all match up right here. So this is what you're going to need to do, is you're going to need to create a message for each topic that you want to send. Now, we can also do is we can do ROS message is another command list, and we can see all of the messages that are in the system right here. Now, there's a bunch of standard modules. There might be other ROS packages that are installed, for example, navigation messages. But here you can see all of ours. These are our custom ones that are in this PiCar. So if I say, so we've got PiCar dash encoder. So I could say ROS message, and let's see, we have ROS message. I can say show, and we can say PiCar dash encoder. Now, and it's really just like going into that folder, but sometimes you don't want to go find the actual package. And you can see also these standard messages contain some of the ones that we're using. Int 8, float 32. Those are defined inside of standard message. So you can use a different libraries or a different packages message inside of your library. So same thing. We can do PiCar health. And it's really just going to be showing us that same information. So, we got node topics, and again, publisher subscriber, this is really meant to be thinking about is how we send information between different scripts. So let me show you, for example, let's go into health, and we can look at how this node is set up. So first thing we're doing is we're going to import ROS Pi. That's the ROS Python library. There are C++ ones if you want to use those. It's a very simple script. So the first thing that's happening is we have our main method. I just print this just to see if it runs. And then what we're going to do is that we have a try except try catch block, and we're going to just run publisher. And if there's some problem, it just catches it here. You could print it. You could do exception as E or whatever and print E. But we're just basically going to be doing is we're just going to be calling publisher. First thing is we're going to set up the publisher. So we want to say ROS Pi publisher, and we have health pub. If you remember, if we go back here, we type in ROS node list. So you can see we've got this. The node is publishing on health with a capital H, capital P. So let's go back in the script and see. This is where that gets defined. This init node, health pub with a capital H, capital P. This is the name. This is where we're actually defining the name of this node. This lowercase is telling us, so this ROS publisher is telling us what topic are we publishing on. And then this is telling us this health comes from up here. From PiCar message, import health. When we compile our ROS library, it's going to create an actual header file. It's going to create a library file for the message file. And now we can reference it, which was that health.msg file. The rate here is saying we're going to run this once per second. So this is basically in hertz. So we're going to run this, and you'll see where the rate is. So basically, as long as we haven't shut ROS down, then we're going to do is we're going to create a message, and we're going to reference that, again, that health message library. And this is where we can then begin to go ahead and define all the different fields. So remember, we had a header. You're just going to use this all the time. You're going to do ROS Pi time now, base link. Don't worry about that, but just put that in. And then this utils, well, this comes from the PiCar library, right? So this is the provided script that PiCar includes with us. So we're going to just fetch this, which I think is already a float 32, so it passes in nicely. CPU usage is not, so we're going to cast that as a float. And then here we're going to be reading the power levels. And then once we have all of this in the message, we simply publish it. So we call pub, which is going to reference this, and then we're going to publish the message, and then rate.sleep. That's where it's going to reference this hertz. How many times do we want to run this per second? So if I do 10, it's obviously going to call this 10 times more often. So if you consider that this calls and this part probably runs in pretty close to 0 time, rate.sleep is kind of just like doing a sleep. You can think Python time.sleep for 1 second. It's kind of doing the same thing. So that's it. And this is going to run once per second. So let's take a look at encoder pub. We can take a look at this one next. So this is publishing the encoder commands. So again, I didn't put this one in a main method like the other one. I probably should have. But what we have here is we've got our, again, we init our node, encoder pub. If you remember, that was one of the ones running, so we can see how that one works. We're going to set the rate to 200. We want this to run 200 times every second, not 1 time. So, much faster than before. I had the queue size set to 10 before. You're probably going to just set it to 0, and again, it means it's just not going to be queuing these messages up. We're doing something, we didn't use their library for reading the encoder. Just didn't find it to be very good. So what we're doing here instead is we're just referencing the Raspberry Pi GPIO library directly. And this is saying is that anytime we have a pull up, if we detect a pull up, then we're going to go ahead and fire this. So we only ran this on one encoder because this can't detect if it goes backwards anyways, so we didn't even see what the point of reading it from both encoders. If one encoder goes, we assume it's moving forward. And then you can see here, this is the callback. So every time we detect an event from the GPIO, then we have this callback function. We run this Lambda call, and what we're doing is we're basically just passing a static value of 1. Every time that GPIO detects that it goes up 1, we're going to just send 1, and 1 being the motor ID. You can see we had one here commented out if we wanted to do it for motor 2. So yes, we're doing a nasty global variable here, but it's not really a true global. We're going to create our message, our encoder message, just like we did before. We're going to pass in the motor ID, and then if motor 1, we're going to set message.value set to that, and then we're going to publish it. Pretty straightforward. Again, if I do ROS topic echo, let's do ROS topic list, ROS topic echo encoder, and again I'm going to just move the encoder by hand, and you can see each time we do that, you can see the value is basically you can think of that as the encoder count, encoder ticks, steps, whatever you want to call it. We just called it value, and I'm just turning this by hand. You can see if I move it pretty quickly, this is real time. It feels immediate. When I move that motor and when it prints on screen, it's very, very quick. Let's take a look at another. We'll take a look at another script we did in here. So let's look at motor subscriber, because we've been talking about how do we publish data. Well, now we want to look at how do we subscribe to it. So what this is going to do, this is going to, well, let's step through and let's see if we can get down to the, so first thing we're going to do, when this script runs, we stop the motors. This is a good starting point. We're going to call listener. Now listener is going to, again, it's going to create our node called motor subscriber. We're going to set the rate to be 200. And now this is a new command here called rospy.subscriber. We're going to subscribe to motor commands. We're going to subscribe to encoder, and we're going to subscribe to orientation. We're going to subscribe to these, and then this is our callback. So this is going to say is anytime we receive a message, this is telling us the message type. So we have motor, encoder, orientation. Now, as you would expect, if you come to the top, from PiCar.message, import motor, encoder, orientation. So we come back down here again, and we're going to say is if motor commands is called, we're going to call some function called callback. We probably should have renamed that to motor listener or something, but let's just take a look at it. So we've got callback. ROS.pi.loginfo. This is a way to log things into ROS as a logging system. But what we're basically saying here is that, you know, we're passing in the data. It is that message type. So we can say data.power. And actually, let's take a look at this motor. We've got this motor message. Let's just look at that. Actually, we can just say ROS message list. We can take a look, and we've got one called PiCar motor. So let's say ROS message. ROS message show PiCar motor. So we've got our header. We've got power, direction, distance. So that's what this is going to be doing. Is it's going to be another script is going to be publishing this message, and it's going to be publishing a power, a direction, and a distance. And this is going to be looking for that. It's going to say, okay, if power is 0, then we're done. Just stop. We don't care about anything else. If direction, so data.direction is forward, then we're going to call move car, and we're going to pass it some distance. And you can see, based upon that information, we can make these. And these turn car, move car, these are these methods up here. So we've got one for turn car, we've got one for move car, and then we're also incorporating, we can see we're also reading encoder counts, and we're reading orientation, and we're taking that into account in the script. But I'm not going to go line by line by that. The big takeaway here is we subscribe to a topic of type message, and then we're going to have a callback function. Very straightforward. And the last thing is something in here called a ROS service. So I don't know if we might be using one of these. So this is in a separate folder called service. The idea here is that where a topic is something that you just, if I'm publishing, I publish, I don't worry about it. I'm not waiting for anyone to acknowledge it. If nobody listens, that's fine. Like right now, we can see if we do ROS topic list, we're publishing on encoder and health pub, and nobody's actually listening to it. And that's fine. I'm gonna move the motor right now by hand. It's publishing, and nobody's listening, and that's fine. Same thing with health pub. The idea with a service is that I'm going, and I'll just show you one. So we've got one for A star. The idea here is that I'm going to be sending some data, and I'm actually expecting something in return. So for example, we've got something of type location. This is a message type of location. We're going to send it to walls, and what we want a response. So this is going to be we send that data out, and this is what we want back in return. So I think there is a command called ROS service, and I think if we do list, it's probably not going to show it because it's not. Oh, okay. Well, it actually does, even though the node isn't running. So if we say PiCar A star search, so we can say ROS service show A star search, and as you'd expect, this is what it's going to have. But what's nice when you run this ROS service is it actually breaks down, and then it says, okay, well, what was location? Because it says custom type, and it says, okay, well, location walls. Location is actually made up of an int32, and this is an int32 array. So we have two different things in there. And then again, same thing. This is going to be int32, and so this is what it's expecting as a return. So again, if we go back in here to message, there is a location.msg file, and again, that's all that's saying is that a location message is just this int32. But when you run this ROS service show, it breaks it down, and it actually shows you what that is. So if we go back to script folder, we could in here there would be one of these. I think it's the A-star search server. And if we run this, this is going to be how you actually run the service. So we'll go down here. We've got A-star search server. We're going to create our node. And now we're going to create something called the ROS Pi service. This is going to be the name of the service. This is going to be the SRV file that I showed a moment ago. And then this is going to be essentially the callback function here. And then that's going to run here. You'll see some other things in here. ROS get parameter. We could talk about those in another video. But this is at least kind of get you started with the basics of nodes, topics, messages, publisher, subscriber, and service.